In this video, we'll explore the different air masses that shape the weather patterns across North America. First, let's examine the air masses in their source regions. In the northern part of the continent, we have four air masses based on their source regions. The continental polar air mass, which forms over central Canada and Alaska. The maritime polar air mass originating over North Pacific, affecting the west coast. Another maritime polar air mass formed over northern Atlantic Ocean, impacting the east coast. And finally, the continental Arctic air mass that forms over frigid regions of the Arctic Oceans and northern Canada. Now, looking at the tropical regions, we have the maritime tropical air mass, which forms over the Gulf of Mexico and the Caribbean Sea. Another maritime tropical air mass that forms over the Pacific Ocean, and the continental tropical air mass which forms over the deserts of northern Mexico and southwestern United States. Now let's take a closer look at the weather patterns associated with each of these air masses. Let's start with continental polar air mass, which often influence the weather in Michigan. Continental polar is a cold, dry, and stable air mass that forms over central Canada and Alaska and gradually pushes southwards into the interior US as a shallow dome of high pressure. This air mass can reach as far south as the Gulf of Mexico and Florida, sometimes causing damaging freezes to crops. The Rocky Mountains act as natural barrier, preventing this air mass from advancing westwards, confining their influence to the east. As the cold, dense air slides south, upslope precipitation can occur on the eastern slopes of the Rockies. In the Great Lake region, during winter, this cold, dry air mass brings frigid temperature and clear skies. When it interacts with moisture from the Great Lakes, it can lead to lake effect snow. In summer, the air mass brings cooler, dry weather, offering relief from heat and humidity. Next is the coldest air mass of all, continental Arctic air mass. The continental Arctic air mass forms over the frigid regions of the Arctic Oceans and northern Canada. It is characterized by extreme cold, dry, and dense air, which leads to clear, bitterly cold conditions. When this air mass moves southwards during the winter, it can plunge into the northern US, causing severe cold snaps with dangerous wind chills and record low temperature. Arctic air masses are typically shallow and hug the ground as they spread, bringing frigid conditions as far south as the central United States. When these air masses interact with warmer, moist air, they can intensify winter storms and contribute to heavy snowfalls. When continental Arctic air mass pushes down into Michigan, it causes bitterly cold temperature, wind chills, and can intensify lake effect snow, especially near Lake Superior and Lake Michigan. Now let's examine the two maritime polar air masses. The maritime polar air mass over the Pacific forms over the cold waters of the northern Pacific Ocean. It is cold, moist, and unstable, bringing cloudy skies, rain, and sometimes snow to the Pacific Northwest, especially during the winter months. As this air mass moves inland, it interacts with the coastal mountain range, causing orographic precipitation, intensifying rainfalls along the windward slopes. After crossing the mountains, the maritime polar air mass can lose much of its moisture, resulting in drier conditions further inland. The maritime polar air mass helps moderate temperatures along the Pacific coast, keeping the region cool in summer and milder in winter. The maritime polar air mass affecting the east coast forms over the cold waters of the North Atlantic Ocean. It is cool, moist, and unstable, often bringing cloudy skies, fog, and precipitation to the northeastern US, especially in winter and early spring. As the maritime polar air mass moves inland, it contributes to storm development along the coast, including nor'easters, which can bring heavy rain, snow, and strong winds. This air mass helps maintain cooler, damp conditions along the east coast, particularly in the New England regions, and can also cause coastal flooding during intense storms. Next, let's move to the tropical region. The first air mass that we will examine is the maritime tropical air mass that forms over the warm waters of the Gulf of Mexico and the Caribbean Sea. This air mass is characterized by warm, moist, and unstable air, which often brings high humidity, cloud cover, and heavy precipitation to coastal and inland areas. This maritime tropical air mass plays a significant role in influencing the weather pattern in eastern and southern US year round. During the summer, this maritime tropical air mass is responsible for oppressive heat and humidity across much of the southeastern US, often leading to afternoon thunderstorms. When this air mass moves northward, it can fuel severe weather as it interacts with cooler, drier air masses. In late summer and in fall, this air mass fuels the hurricanes. The maritime tropical air mass from the Gulf of Mexico brings warm, humid conditions to Michigan, particularly in late spring and summer, often leading to oppressive heat. As it moves northward, it triggers thunderstorms and increases rainfalls, resulting in heavy downpours. In winter, this air mass can cause milder temperature and mixed precipitation when it interacts with colder air from Canada. Now let's move to the west coast. The maritime tropical air mass formed over the Pacific Ocean significantly impact the western US, particularly the southwest. When it moves inland, it brings warm, moist air, leading to increased humidity and occasional rain, especially in late summer and early fall. The maritime tropical air mass fuels the North American monsoon, resulting in thunderstorms and heavy rains in Arizona, New Mexico, and southern California. Additionally, it enhances summer heat and humidity, making heat waves feel more intense. While it loses much of its moisture before reaching northern areas like Oregon and Washington, this air mass still influences weather patterns in the southwest US. While the maritime tropical air mass over the Pacific is not as impactful as its Gulf of Mexico counterpart, it still influences the southwest US with moisture and storm activities. The last air mass in this review is the continental tropical air mass. The continental tropical air mass forms over hot, dry land areas, primarily in regions like the deserts of northern Mexico and southwestern United States. This air mass is characterized by hot, dry, and unstable conditions, especially during the summer months. As it moves northward, the continental tropical air mass can cause heat waves, bringing scorching temperatures and arid conditions to the central United States. It can also contribute to droughts and enhance wildfire risks in areas it affects. Unlike the moist air masses, the continental tropical air mass produces little to no precipitation, but when it interacts with maritime tropical air, it can trigger severe thunderstorms. The boundary between continental tropical air mass and maritime tropical air mass is often called the dry line. In conclusion, understanding air masses is crucial for predicting weather patterns and their impact on our daily lives.